Hello! Now we're going to work on the second part here with talking about nonlinear intrinsic clearance. As we mentioned, that is one of the areas that can exhibit nonlinearities. If you recall, this is the big equation based upon the Wellster jar model of hepatic clearance. Blood flow, hepatic blood flow times, so Q times E. This is our E for the Wellster jar model. And we can talk about intrinsic clearance, which is enzyme activity. And as you can see, it's Vmax over Km plus C. So this is what determines this relationship between Km and C is what determines whether it's linear or not. Same thing for binding, which will determine your fraction unbound. Concentration bound over concentration unbound. Again, Michaelis-Menten. This relationship here will determine whether or not there's the concentrations achieved will put you into the nonlinear range or not. So both intrinsic clearance and binding are saturable, which are the determinants of hepatically cleared drugs that have low extraction. Remember, their clearance is dependent upon enzyme activity or intrinsic clearance, as we're going to discuss now, times fraction unbound. So as you recall, intrinsic clearance is Vmax, which is the maximum rate at which drug can be metabolized. In this case, this is really about the number of enzymes available, or the capacity of the system, over Km, which is the affinity of this system, and it's defined as the concentration where you achieve half Vmax. So it's where half of your enzymes are full, and concentration is your third component here. For most drugs, Km is much greater than concentration, so concentration falls out in importance, and you end up with really just being dependent upon the capacity and the affinity of the system. Concentration falls out in importance, and then this will be linear, won't it? And this is what usually happens. So as concentration increases, it's not a variable to determine intrinsic clearance. Therefore, intrinsic clearance remains constant with changing concentration when you have a linear situation. If you have a nonlinear situation and it's no longer true that Km is much greater than the concentrations, if that is not true, then you have to keep the concentration in the denominator. And as concentration increases, you can see that intrinsic clearance will decrease. You can also think about the fact that as you saturate the enzymes, the intrinsic clearance will start to fall as you reach this critical point. This is concentration dependent or zero order or capacity limited nonlinear intrinsic clearance. All right, thanks.